Hello everyone. So my name is Shreya and today we are going to study a very important topic which is nucleophilic substitution reaction of alkyl halide. So this is a very important topic of your chapter Hello Alkenes and Hello Arenes. So we are going to cover this topic in this lecture. So have you heard about what is nucleophile, students? So nucleophile is an electron rich species which can donate its electron which has lone pair which has a negative charge. So that species or that basically substance is known as a nucleophile. For example, OH minus, F minus, okay, NH2. So these all are the nucleophile. And what is alkyl halide? You know the general representation of alkyl halide, that is Rx. X is the halogen, beta halogen, and R is your alkyl group, of course, right? So we are going to study nucleophilic substitution reaction of alkyl halide in this chapter, in this lecture. So beta, what happens? Like, Rx bond is polar in nature. This bond is polar in nature. Why? Because X is more electronegative. X is more electronegative than R. And it pulls the electron density towards itself. And for that reason, R will acquire the partial positive charge and X will acquire partial negative charge. Right? So, due to this polarity, the bond will break, and for that reason, we can study nucleophilic substitution reaction of alkyl halide. Okay, so this is a basic thing, or you can say basic concept, like how or why nucleophilic substitution reaction takes place of alkyl halide. Now, there are two methods. So, beta, there are two methods or two mechanisms, you can say, two basic mechanisms, you can say, by which nucleophilic substitution reaction of alkyl halide takes place. So, what are those methods, ma'am? The two methods. What is SN? One is SN1 and the another is SN2. Okay, so we will cover one by one both methods, right? Good. So first of all, we will study about the SN1 reaction or the SN1 mechanisms. Okay, so like what is SN1, what is S, N, and 1 represent here? Okay, so S means substitution, N means nucleophilic, and 1 means first order. So, students, have you studied about the chemical kinetics? You already have studied about the chemical kinetics in your physical chemistry, where you have studied about the different order reactions, zero order, first order, second order. So, SN1 reaction is of first order. Why, ma'am? Why it happens? We will study, right? So, what happens if we will take one alkyl halide, for example, Rx, and if we take a nucleophile, so what happens? Nucleophile substitutes the X and X will leave. X is the leaving group here, and you will get a product RNU plus X negative. So this is the basic mechanism I am telling. This is like basic step of the nucleophilic substitution. So what happens actually in SN1? There are the two steps. There are the two steps. Okay, what are those two steps? What happens in the first step? The bond of R and X breaks and we get R positive. So like X will take both electrons to itself and R positive will form, which you know is known as carbocation. You know very well this species is known as carbocation because it has a positive charge, and of course R group has a carbon and carbon has a positive charge here, right? So first step is this. What happens in the second step? In the second step, R positive, or you can say nucleophile, attacks you because nucleophile has negative charge. It is in search of positive charge. Positive charge is in search of negative charge. So nucleophile will attack on R positive and you will get product RNU. So this is our final product. As you can see, nucleophile has substituted the X. Nucleophile has come here, X has gone, right? So these are the two basic steps which happens in the SN1 or the nucleophilic substitution reaction. So in SN1 and SN2, in both mechanisms, in both reactions, substitution takes place, but the ways or the method or you can say mechanism is different. Okay. So in SN1, these two are the basic steps. Now we will study about some basic characteristics or the basic properties of the SN1 reaction. So what are those properties? So as you can see here, the first point we get from here that this reaction or this mechanism happens in two steps, right? The second property you can see the formation of carbocation takes place, right? So we can say in SN1 formation of carbocation takes place. Okay, I'm writing like this. Formation of carbocation takes place. Very good. Now, question has come to your mind like, ma'am, tell about what is first order. Why you have written this is first order? What does it mean? Right. So, students, why we have written first order here? Because the rate determining step decides the overall rate law, right? So, among these two steps, the first step is rate determining step, which is called RDS. Formation of carbocation is the RDS step here because this step is slow. This step is slow. This is happening slowly, slowly. The breaking of RX bond is taking place slowly, slowly, and that's why this step is rate determining step. So we can write our rate law as K, which is a rate constant, of course, and the reactant or the substrate is alkyl halide here. So we can write alkyl halide, and of course, power is 1. So that's why this mechanism is first order because rate is solely depending on the alkyl halides concentration. It is not depending upon the nucleophiles concentration. It is only depending upon the alkyl halide concentration which is present in the first step, which is present in the slow step. Great. Now, here we can say this is unimolecular reaction. Unimolecular. See, we can also write one as unimolecular. Okay. As you can say, only one molecule is taking part in the RDS step. So this is unimolecular reaction. Right. Okay. Great. Now, the one important point, students, we use here polar protic solvent because every reaction takes place in particular solvent. We use polar protic solvent here. What is polar protic solvent? Which is polar in nature and which has H plus ions. Very simple example you can take, for example, H2O. This is polar and it can donate H plus ion. So this mechanism happens in polar protic solvent. That is a very important point here. Right. Now, the sixth point is, see, there are the different type of alkyl halides. You have studied already. That is 1 degree, 2 degree, 3 degree, right? So here we can say the rate depends upon the alkyl halide, type of alkyl halide. So the rate is faster in the case of 3 degree. It is less in 2 degree and least in 1 degree. Why? Why it is happening? Because 3 degree carbocation is more stable than 2 degree carbocation and 2 degree carbocation is more stable than 1 degree carbocation. That's why this is happening that 3-degree alkyl halide has more rate. If you take 3-degree alkyl halide, if you take 2-degree alkyl halide, and both are showing nucleophilic substitution reaction, 3-degree will show reaction immediately. 3-degree will react immediately because it has a faster rate as compared to the 2-degree and the 1-degree. So that is a very important topic here, right? Okay. Now, the seventh point. See, as you can see, nucleophile is present in the second step, which is not rate determining step here, right? Nucleophile is present in second step, so you can take any type of nucleophile here, strong or weak, it doesn't matter. Okay, strong or weak nucleophile you can take because the rate is depending on the type of carbocation forming, so that is the important thing. Okay, so these are the basic or the main characteristics about the SN1 reaction. And in the last, we will study the difference between SN1 and SN2. But before that, we have to study SN2 mechanism, right? So this is clear. This is okay. Fine. Great. So we can take an example also. We will take one example. For example, we take CH3, CH3, CH3 and Br. So this is alkyl halide. Which type of alkyl halide is this? This is the 3-degree alkyl halide, of course, because the bromine is connected to the carbon, which is connected to the 3 carbons. That's why this is 3-degree alkyl halide. Now, what happens? The bond of C and Br will break. Uh, this is like this. Okay. The bond will break like this. Okay. So the bond will break and the formation of carbocation takes place here, right? And this is the RDS step of our mechanism. Now, this is a first step, and I told you about the second step. What happens? This is a RDS step, and what happens in the second step? The carbocation will undergo further reaction, right? So, for example, if we take the nucleophile as OH negative, hydroxyl ion, right? So, it will attack on the positive charge, and the final product we get here is alcohol. Great. So, this is happening here. And of course, we take H2O as a polar protic solvent or any other polar protic solvent here. So this is a one example of SN1 reaction, students. So I hope this is clear to you. Great. Now, if you want to study about the stereochemical aspects, what is the stereochemical aspects? So like if we want to discuss about the stereochemistry, if we want to discuss in 3D, what happens? I will discuss this in short here and then you will study in detail later. Okay, so what happens? As you can see here, the formation of carbocation is taking place, and you know, carbocation is planar. Its geometry is planar. So, nucleophile can attack from above and below both. Okay, so it can attack from both, and that's why we will get racemized product here, or you can take you can say racemization takes place here. So what is racemization? Racemization means you will get 50% R product and 50% S product, right? For example, if the alkyl halide you have taken R here, for example, so you will get 50% R alcohol and 50% S alcohol. So racemization takes place here, right? Great. Okay. So now we will study about our second mechanism, which is very important, which is also equally important. That is a SN2. So SN2 means nucleophilic substitution, bimolecular nucleophilic substitution. So here also what happens? The first point is it happens in the first only one step. It is a one step mechanism. एक ही बार में हो जाएगा one step. Okay. So what is one step? Like if you take alkyl halide CH3X. Okay. And if you take nucleophile, any nucleophile, so what happens? The bond breaking and the bond forming simultaneously takes place. Like this is X and nucleophile attack from the back side. Okay, I am showing little bit dark line for the nucleophile. It is forming bond with carbon. It is breaking bond with carbon. And of course, hydrogens are present here. So this is called transition state. What we call transition state. What is transition state? It is the state where the bond breaking and the bond forming both are happening at the same time, and we will get ultimately our final product CH3, and the nucleophile, this is CH3, and the nucleophile will come here. Right. So this is our final product. So this is the only one step reaction. Okay. Now you can see here only the transition state will form. So the second point is transition state will form, and transition state is not stable. That's why it breaks and we finally get our product. The third point is it is a bimolecular. What does it mean bimolecular? Bimolecular means there are the two reacting species here, and if as I told you, this is a one step reaction, this is the only rate determining step. So we can write our rate law as rate will depend upon alkyl halide, also on nucleophile. So 1, 1 and 1 plus 1 will give you order 2, right? So that's why this is second order and this is bimolecular, because two molecules or two reacting species are present in the rate determining step. Transition state is forming here. So what other points we have studied about the SN1 reaction? um if we compare, so we have covered all this, huh? Now the another point is about solvent. So here we use polar protic solvent, sorry, polar aprotic solvent. What is aprotic solvent? That is polar in nature, but it does not contain H plus ions to release. For example, you can say TMF, DMSO. Okay, so these are the polar protic solvent here we use. And the sixth point here, you can see the nucleophile has attacked from the back side. So here the steric factor is very important. So what is steric factor? Like nucleophile wants space to attack. The alkyl halide, which has more space, which is less bulky, which is not containing more of the area, nucleophile can attack easily there, right? So that's why the rate of alkyl halide, if we see 1 degree alkyl halide will react faster, 2 degree slower, and 3 degree least rate. Okay. So if you take 1 degree alkyl halide, as you can see, this is a 1 degree alkyl halide, and if you take 3 degree alkyl halide, as we have studied in the SN1, so you can see in 3 degree alkyl halide there the carbon is containing the 3 methyl groups, which is occupying a more of area. So it will be harder to nucleophile to approach here and to attack the carbon. But here you can see in the case of 1 degree alkyl halide, it is very easy to attack because it has very less bulky group or the smaller group hydrogen. So nucleophile can attack easily. So steric factor has very important role to play here. So we can say ki 1 degree has more rate and 3 degree has least, 2 degree in between. So these are the very important characteristics of the SN2 mechanism. Now coming to the stereochemical aspects, as you can see, nucleophile is attacking from the back side here. So if X is present in the front side and nucleophile is coming and is attacking from the back side, so we will get the inverted product. So what is inverted product? Like you will get the inversion here. Inversion, or you can say inverted product here. Because, for example, if the configuration of this compound is R, you will get product S, because nucleophile has attacked from the back side. Okay. For example, if you take like this, bromine, hydrogen, hydrogen, and hydrogen, right? Now OH negative as nucleophile is attacking from the back side. So what happens? Hydrogen, 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 and the nucleophile will come at this position. So this is not chiral carbon, but if you take chiral carbon and you decide the configuration, like if it is R, so then it will become S. Okay, so these are the very important mechanism. In last, we will study about the basic differences about the SN1 and SN2 mechanism, right? So I will summarize. So uh, see, in SN1, the mechanism was two-step, right? One is rate to mining step, second is attacking of nucleophile. In SN2, that was one step reaction. Nucleophile is attacking, leaving group is leaving, both is happening at the same time. Now coming to the rate law. Rate law we have defined in SN1 that it only depends upon the substrate's concentration, which was alkyl halide. And in SN2, substrate and nucleophile both matters, right? Okay, so coming to the stereochemistry, I have told you in SN1, racemization takes place because carbocation is planar and nucleophile can attack from both the sides. And in SN2, inversion happens because of the backside attack of the nucleophile. Now, substrate preference, I told you in SN1, tertiary is preferred because it tertiary carbocation is more stable, right? Right, and like you can say 1 degree will not show SN1. Okay, 1 degree will not show SN1. And in SN2, 1 degree has the fastest rate. Okay, or you can say methyl halide, and primary and secondary, this is a order. And for solvent, you have seen in SN1, polar protic solvent can be used, for example, H2O. And in SN2, we use polar aprotic, for example, DMF, DMSO, dimethyl sulfoxide, and all that, right? So I hope you understood this lecture very well. Thank you.